In this video, we are going to clarify the relationship between chemical equilibrium constant of a chemical reaction with temperature based on La Chatelier principle. So, what is called chemical equilibrium constant? In the previous video, we have discussed already that chemical equilibrium constant are nothing but Kp and Kc. So in this video, we are going to establish a relation between Kp and Kc with temperature T. So before going to that, let's focus on a different thing. In thermochemistry, a reaction can be divided into two categories. So what are the two categories? One is called exothermic reaction. Exothermic reaction, and other one is called endothermic reaction. Endothermic reaction. So what is called exothermic and endothermic reaction? Exothermic reactions means where the system release heat energy in briefly, and where the system consume heat energy, this is called endothermic reaction. So let's describe this with perfect example. So let's have an example where N2 reacts with 3H2 to produce 2NH3, where the delta H is negative. So what is delta H? Delta H mean the overall standard enthalpy changes in a reaction. So for this reaction, the delta H is minus 92.2 kilojoule per mole. This reaction can be written as N2 plus 3H2 to produce 2NH3 plus 92.2 kJ per mole. That means 92.2 kilojoule per mole amount of heat energy released or produced here. So now let's have example of endothermic reactions where N2O4 reacts to 2NO2, where the overall standard enthalpy changes is positive, and that is plus 55.3 kilojoule per mole, where the system consume 55.3 kilojoule per mole. These equations can be written as N2O4 plus 55.3 kJ per mole to react to 2NO2. So these are the example of exothermic reactions and endothermic reactions. Now come to the point. If we increase temperature or provide heat energy for an exothermic reaction, that means we have increased the right side of the reaction. That means according to the La Chatelier principle, the chemical equilibrium position are bound to move to left side of the reaction, causing the concentration of the reactants increased. That means the concentration or amount of reactant increase and the concentration or amount of the products decrease. So if we write the equation of Kc here, we get NH3 concentration square N2 and H2 to the power 3. So we have said that the concentration of NH3 decreased and the concentration of the reactants N2 and 3H2 increase. So as a result, the amount of Kc decrease. So let's have a summary. We have increased the temperature or provide heat energy. As a result, the Kc decreases. Now come to the left side of the endothermic reaction. If we increase temperature or provide heat energy for an endothermic reaction, that means we have increased the left side of the reaction. So according to the La Chatelier principle, the chemical equilibrium position are bound to move to right, causing the concentration or amount of NO2 increases and the concentration or amount of the reactants N2O4 decreases. So if we write the equation of Kc, we get NO2 square divided by N2O4. This is the equation of Kc over here for the reactions of N2O4 reacts to 2NO2. So we have said that as we increase temperature, the amount or concentration of NO2 increases and the amount or concentration of N2O4 decreases. As a result, the value of Kc or the value of the fraction Kc increases. So let's have a summary for the endothermic reaction. We have increased the temperature over here and the Kc increases for this endothermic reaction. So we can say that if we increase temperature for exothermic reactions, the Kc decreases, and if we increase temperature for endothermic reaction, the Kc increases. So the relationship between chemical equilibrium constant and temperature can be written by an equation famously known as Van 't Hoff equation. This is Van 't Hoff equation. Van 't Hoff equation. So the equation is log Kp is equal to minus delta H by 2.303 R into 1 by T plus constant. This is called the Van 't Hoff equation to describe the relationship between chemical equilibrium constant with temperature. This equation can be compared with the straight line equation. How? We can compare log Kp with y, we can compare this with m, this one with x, and this constant with c. So we know that y is equal to mx plus c is a standard equation of a straight line. So if we plot 1 by t over x-axis and log Kp over y-axis, we will get a curve look like a straight line. So we are going to draw the curve both for exothermic reaction and for endothermic reactions. Here, two curve will be get for this one is for exothermic reaction and this one is for endothermic reaction. We are going to plot 1 by t over x-axis and log Kp over y-axis. Here 1 by t over x-axis and log Kp over y-axis. Now think carefully. We have said that if we increase T for an exothermic reaction, the chemical equilibrium constant Kc or Kp will decrease. We have said that earlier. If we increase T, that means we have decreased 1 by T. But for this graph, we have plotted 1 by T over x-axis. So if we increase 1 by T for this x-axis, 1 by T increase, that means T decrease. If T decrease, Kp will definitely increase. So this indicates that if we increase 1 by T over x-axis, we will get Kp increasing. So we will have a straight line look like this. That means if we increase T over x-axis, this log Kp will increase over y-axis and we have a straight line look like this. Now come to the endothermic reaction. We have said earlier that if we increase T for an endothermic reaction, the value of chemical equilibrium constant will increase. If we increase T, that means we have decreased 1 by T. But in this graph, we have plotted 1 by T over x-axis. So if we increase 1 by T over this, that means T decreases. If T decreases, Kp definitely decreases. So if 1 by T increases, the Kp decreases. So we'll have a straight line look like this. That means we have increased. That means we are increasing 1 by T over x-axis and we are having Kp over y-axis decreasing. So these are the two graphs of both exothermic reactions and both endothermic reactions, and this is the explanation of Van 't Hoff reactions. So I think definitely this video will be very helpful for you, and don't forget to subscribe this channel and love and share this video.